Okay, so for 5.1, we're doing polynomial functions. We're going to name it by the number of terms. Really, you have three that you have to worry about. You've got monomial, binomial, and trinomial. And everything after that, if it's four or more terms, where n is just the number of terms, so if it's got 5 terms in it, that is called a 5-term polynomial. If it's got 6 terms in it, it's a 6-term polynomial. So once you get past 3, there's nothing really fancy about it. It's that many terms polynomial. It's a 4-term polynomial. It's a 5-term polynomial. It's a 6. If it's got 10 terms, it's just a 10-term polynomial. They don't have any extra special names after you get past monomial, binomial, and trinomial. They're all just basically the same thing. Okay, and then the other thing they're going to ask you to do, they're going to ask you to take a polynomial function. You're going to name it by the number of terms. You're also going to name it by degree. And when we do this, we're going to make a little chart here to kind of help us out. Okay, and when they talk about the degree, when we name this thing by degree, just remember your degree is your highest power. And for this, we're going to say it's the highest power of x. Now, most of the time they'll stick with x. They may sometimes occasionally give you an n or a t or something, but they usually stick with x when it comes off this thing. All right, and I remember this one, somebody was asking me this. I think it was after some test they had taken, and they were talking about what's a constant. And we were like, and it was one of those things we'd covered this like a week before they had done something. I forget now which test it was. But anyway, we came back and I was like, constant. I'm like, that's where it doesn't change. And they were like, what do you mean? I'm like, well, nothing ever changes. So if you have an equation, basically, we'll give you an example over on the side of here. This would be like y equals 4. Because on this one, there is no power of x. So in this case, your degree would be 0. So they call that a constant. All right, linear. Again, when we just kind of separate this over here. Basically, everything here is an example of what we're going to talk about. This is the name of it, and this will be an example that's over here. If it's linear, think about when we're graphing some type of line. You know, if it was 2/3 x minus 5 or something like that. If you put it back in y equals mx plus b form, which is basically what we have here, that this would be x to the first power. So if you have something that's a straight line, when you were going to graph it, they're going to say that's linear, which basically means you have a degree of 1. That you've got x to the first power, so it's just 1x that's there. All right, now here's where we kind of jump back to what we've just finished up doing. Graphing and solving and factoring and all that stuff. Quadratics. Now, and here's where you have to make sure you stick with this one. A lot of times people say, well, if it's quad, that means 4. Well, it is. But if you remember, when we did the quadratic equation, we always started off with x squared. So if you're talking about something that's got a degree of 2 as your highest power, then that's going to be a quadratic. All right, if we go to degree 3, you do something to the third power. If y'all remember back, the one shortcut you have for that one was you could say that was something cubed. Well, in that case, they call this one cubic. So maybe it's like negative 4x to the third minus 5x plus 2. The main thing is, again, that you're always going to your highest power of x to figure out what the degree is going to be. Again, in that case, for this one, there'd be an understood x to the first power that would be on that one. And if there is no x, then that's what they call a constant. So that's 0. Okay, so quadratic is 2, cubic is 3. For 4, well, that one does make sense. It's quartic. there's 4 quarts in a gallon, there's 4 quarters in a dollar. If you're in a football game, there's 4 quarters in a football game, that kind of thing. So if it's quartic, that one would be to the 4th power. All right, so quartic, because there's 4 quarts in a gallon, so this would be degree 4. And again, you don't have to have all the terms. It could just be that's x to the 4th plus 6x squared plus 7 or something like that. All right, and then the last one that we're going to look at is quintic. Well, if we keep going down the line there, 1, 2, 3, 4, 5. Maybe something like that. But again, if you name it by degree, the main thing is you find your highest power of x. And whatever that highest power of x is, that's telling you what the degree is going to be. Okay, now one thing I probably should have mentioned back up here when we're talking about the number of terms on this one is that when you talk about the terms for everything that's here, okay. That when you name this by the terms are separated by pluses or minuses. Yes. Oh, sorry. Yeah. All right, so your terms are separated by a plus or a minus, and then the other thing we're going to do here, and this will be the last thing we're kind of put all together, is they're going to talk about standard form. And y'all know, most of y'all know what standard form is because you've heard it a million different times. They may not have called it that. This is basically an equation or expression. In descending order based on the powers of the variables. Okay, so standard form is you start with your highest power, and again, most of the time that's going to be x, but you start with your highest power of x, and then you keep working down in descending order. And usually if you do that, it's kind of like the examples we had that were back up here, that if you do that, your degree is always based on your first term. So if you do that part of it, your first term is always first. That tells you, what your degree of that equation is going to be, or the degree of that expression is going to be. All right, so here's what we're going to do. We're going to take just some different examples, show you how to write it, classify it by terms, classify it by the degree, all that stuff, go back and do everything with it, and then show you the only way they could give you a trick question when it comes off these, because there's really only one possible trick question they could get that might throw this thing off just a little bit. So we're going to write the expression in standard form. We're going to classify it by degree. And by the number of terms. Okay, so here we go. Give you like 3 examples just to make sure everybody's okay with what's happening here. Let's do 3x to the third minus x plus 5x to the fourth. Okay, now it may be simple, little easy things to think about, but this is something, again, if you're doing this one online, working through the problems, the easiest thing to do for me is I always go back and just rewrite the problem. Or, in this case, you'd have to write it down because it's going to be shown to you on your screen. And just remember that every sign goes with the whatever number you have, the sign has to go with it. So this plus has to go with that x to the fourth with 5. The minus has to go with the x. And there's not a sign with a 3, but if it had one, that would be a plus that would be in front of it. So it's a positive 3x to the third. And for me, that's the easiest way to find the number of terms because you got the pluses and minuses to separate everything. But the sign will always go with the number that's to the right of it. So that plus goes with 5, the minus goes with what basically would be an understood 1 that would be there, and the positive would go with 3. That way it's easy to see in this case that you have 3 terms. And it may be something that's kind of, people are like, oh, that's really easy. But sometimes it's the easy questions that sometimes you glaze over them so fast that you kind of miss it. So this is one of those things, if you slow down for just a second and just make sure you start, every sign has that number that goes with that sign, and just kind of go back and go with it from there. So it's 3 terms. They might also just make you say it's going to be a trinomial. Sometimes they go with one, sometimes they go with the other. Whichever way, we'll kind of put them both just to be on the safe side. All right, and then once it's here, to put it in descending order, that's going to get us in the standard form. So you start with your highest power of x. So that is 5x to the fourth. You go to your next lowest power of x, which would be the 3x to the third, and that was going to be a plus. And then the minus would go with the x, and that would go there. So that's going to be standard form. Okay, and again, the big reason they have you put that in standard form is that once you do that and you got your highest power of x here, you know what your degree is going to be. So the degree is going to equal 4. That whatever your highest power of x is, that's what your degree is going to be. Now, again, they may leave it as degree like that, or they may make you say that it's going to be quartic. It's kind of back and forth. Sometimes they let you just put the number. Sometimes they'll give you the name. It just depends on one question. That's kind of what they go through there. All right, let's go one more of those and we'll show you the trick question. That's all you have to do? Yeah. Yeah, so most of them, they're probably going to have you, sometimes they may have you do like 2 of these. Sometimes it may just be you're going to rewrite it in standard form and then just tell me the degree. So it could be that they may just ask for 2 of the 3 things, but we're just going to show you all 3 just to be on the safe side. All right, so for example 2, we'll go with 3 minus 4x squared plus 5x minus 10x to the third. All right, and again, it's if that's the question that you get online, I would say take out a piece of scrap paper, just any kind of piece of paper you got, and again, just to be on the safe side, just make sure you take the sign to go with that number. All right, and the 3's by itself, so if you've got the number in front, if it doesn't have a sign, then basically that would be a plus 3 that would be there. So the minus goes with the 10x to the third, the plus goes with the 5x, and the minus goes with the 4x squared. Again, you got the plus 3. That way, every how many circles you have, that's how many terms that you have, so that is 4 terms. Okay, and again, if it's 4 terms, it doesn't have a special name. And basically there, it's just a 4-term polynomial. It doesn't have a special name because they just said, all right, that's good enough. 1, 2, and 3 terms, only ones get something special. Okay, and then once you've got all the terms separated, you know how many terms that you have. Again, you go back to the highest power. Negative 10x to the third is your highest power of x. Next one we have is x squared. Then we have 5x, and then plus 3. And the whole point of getting it in descending order, which again, we'll talk more about this tomorrow when doing everything we have to do. But once we got it in descending order, got it in standard form, the main thing, one of the big reasons to do that is that, again, that highest power of x is your degree. And again, they may give it to you where it's just degree 3. They may also have you come back and name it. So if you had to name it, it would be cubic. All right, now here's the only way they can give you a trick question when it comes off of one of these. So we start off with something like this. So we've got 16x minus 10 plus 5x squared plus 12 minus 9x. All right, here's what makes this one a trick question. The only trick part on this one is basically you ask yourself on this one is that, can you combine like terms? Right here. Well, you could, right? Because you've got a negative 10 plus 12 that you could do. And if you look at those two terms, you've got negative 10 plus 12. You've also got a 16x and a minus 9x. So basically, you have to go ahead and combine your like terms first. Because a lot of times people say, oh, well, there's 5 terms. Because if we go back and start counting all the numbers, there's 1, 2, 3, 4, there's our 5. But if you actually put these together, if you do 16x minus 9x, you go ahead and combine those two together and make that 7x. You've got negative 10 plus 12. Well, if you go ahead and do negative 10 plus 12, you can make that plus 2. And then you've got the 5x squared that's hanging out on the end of it there. Okay, so if you can combine like terms, you go ahead and do that first. And then once you combine your like terms to get down here, now you start counting, you classify everything based on this. So you're going to classify according to this expression. Okay, so what looks like 5 here, once you do some combining like terms and get to here, well, now you've got 1, 2, 3 terms. Or again, trinomial. If you rearrange everything in standard form, we're going to start with 5x squared. Then we have the 7x, and then the plus 2. So there's our standard form. And then the last thing they would ask you to do is, again, you go back to your highest power of x, which would be x squared, which means then this thing would be degree 2. Okay, and again, they may not give you degree 2. They may give you that list of quartic and quintic and cubic and all that stuff. Well, in that case, if it's degree 2, then it would be a quadratic. Okay, so that's the only way that they can really do a trick question, is that if you've got some like terms that you need to go back and combine in like terms, you do that first. And then you get it down to where it's a simplified expression as much as you possibly can. And then once you get here, then you tell me how many terms you have, rearrange it so you get your highest power of x first, and you keep counting down from there to get the standard form. And then you can go back and tell me what your degree is based on that part. That's the only way they can throw a trick question at you. Everything else is really straightforward, really just, okay, you just count it and you look at it, and that's pretty much about it. Okay. Now when we're talking about polynomial equations and polynomial expressions, that could be anything from, most of the time they talk about it where it's degree 2 or more, but really it could be all over the place. It could be something that's even a first power degree. But most of the time we talk about degree 2 or more. There could be some other ones that they mix in there. And what we're going to do is we're going to kind of touch on this a little bit today with graphs, and then we're going to kind of get a little bit more in depth tomorrow. But basically, we're going to look at some end behavior graphs. All right, now here's the thing. Y'all have already done this a little bit. We've talked about it, but we haven't really like sat down and written it out on a piece of paper, and we kind of describe everything that's here. Because y'all don't have to write this down, but let me just flash back to that last test that was due on Sunday. What if we were doing on the last test, you were graphing something like this? All right, how do we know what's the direction of this graph going to be? Which way do we know it opens? And how do we know that? Yeah, because this number was positive, right? And we said if this A value was positive, we knew that it had to do something like this, right? And here's what we're talking about with end behavior. We're saying, all right, don't worry about the middle part of this, because we're going to worry about the middle part of it a little bit more in the next couple of days. For right now, we're saying, all right, forget about the middle of it. Just tell me what's happening on the end of this graph. So forget about the middle for a minute. Just forget about this for a second. So in this one, we know that both ends were going to go up, and that was kind of what we're doing. And that's what we're going to do today is you're just going to tell me, all right, what happens on the ends of the graph? Tomorrow, we'll come back in and talk about the middle of the graph and figure out what that's going to be exactly. But today, we're starting, one piece at a time. And today, we're worried about just on the ends of this one. So we're talking about this one. This would be that the left side is going to go up and the right side is going to go up. Okay, so that's kind of what we're looking at. All right, so when we're describing these, here's basically what we're going to do. When we're talking about the end behaviors, we're basically saying that this thing is written in standard form. So when we talk about the end behavior of the graphs, we're talking about this being from standard form. So we've got it rearranged. So now we've got our highest power of x is our first term. And we're going to make a little box here where we've got three different things. There's only two options with the first term. It's either positive or it's negative. There's nothing else it can be. So when we talk about the first term of the expression or the equation, whatever it is that they give to us, first term is either positive or negative. There's nothing else that it can be. Okay, and what we're going to do is we're going to basically go on this part of it, that if we have, x to an even power, and again, if you just want to think about it, that you don't have to necessarily write this down unless you just want to. This would be if we're talking about x to the second or x to the fourth, whatever the first term is, as long as it's x to an even power, it's going to be like the quadratics that we were doing with this part back here. That if the first term is positive, they're both going to go up. So if it's positive, we're just going to say that the left side is going to go up and the right side is also going to go up. And when you start looking at the homework questions, it's just going to show either up and up or up and down or down and up or that kind of thing. So it's really pretty straightforward when it comes off of it. And if you want to, I'll show you one in the homework here real quick just so you can see it. There you go. They give you four choices. It's either up and down and up and up, or down and down. The one on the left is always your left-hand behavior, what's going to happen on the left side of it. The one on the right side is telling you what the right side is going to do. So left is left and right is right when it comes off these. All right. If x squared or x to the fourth, any of these things were negative, well, it's just like what we're doing before with the quadratics. Now they're both down. So the left side is going to go down and the right side is going to go down. All right. And if something's not even, and we're talking about something that's odd, so it's x to an odd power. And again, technically they're thinking about like x to the third and x to the fifth and x to the seventh when it comes off of it. They don't really put x. I mean, x to the first is kind of, I always think about x to the first as being, we'll go ahead and throw it in here, because it's just x. Because that to me is kind of the basics of it. Think about something that if it was just like we were talking about earlier, if it was x to a power, so that could be like slope. So we're doing like, half x plus 3 or something like that. Well, just think about what that would look like if you were to graph this problem. That's a positive slope, right? So the right side's got to go up and the left side's got to go down. So this one's going to be very similar to that one. That, again, if we're talking about what's happening on the right side, this one's going to be up. But on the left side, it's going to be down. So everything over here in the odd powers, think about slope. If it was something that was a negative slope, if it was negative 1/2 x, so now it's the opposite. Now the left side is up and the right side is down. So this one will be the same way. This is going to be up over here and then down over here. All right, so here's what we're going to do. Let me just give you some examples. There is really no trick questions on this one because there's not really much they can do for this thing. So they're going to ask you just to determine the end behavior. All right, sorry, we can see a little bit better. There we go. So y equals negative 10x plus 15x squared. All right, now here's where the standard form part of it comes in. Basically, here's all you have to do. You just worry about the highest power of x, which makes it your degree. So in this case, the degree would be 2. But here's really all you need to worry about. It's positive, and it's x to an even power. So all you're going to do is you're going to go back to the chart, positive or negative. So we know we're here. And we're going to find the one that's x to an even power. That's here. So the answer is going to be up and up. There you go. That's all you have to do. No tricks to this one at all. So it's just going back to the chart, find out what it is, and then you just compare your numbers together.
So it would be like the highest power.
All right, so let's say you've got negative x to the third plus 2x squared minus 10x plus 5. All right, this one is in standard form, so it's good to go. We need that first term. And again, you only need 2 things off of it. First off, tell me if it's a negative or positive, so it's negative. And then it's x to an odd power. So then back on our chart, just finish up here real quick. We'll need negative and x to the odd. So here's our negative. Here's x to an odd. So we'll need up and down for answer. So the left side's up and the right side's down. There you go. There's your answer. Okay, and that's it. So as long as you've got the chart, it's really, really, really straightforward. The hardest thing you have to do is you have to go in and just find out what your first term would be if you were going to write this thing in descending order. All right, give you one more. All right, let's do something like that. Negative 12x to the third plus 16x squared plus 22x to the fifth minus 4. All right, again, find what would be your first term. They call it the leading term. So that would be your highest power of x. In that case, would be the 22. It is positive. It's x to an odd power. If you go back to your chart, find the positive x to the odd, that means the left side is down. And then the right side is up. Yeah, that's it. So it's just some combination of up and down. And again, if you've got the chart, it makes it really, really, really straightforward because it's just based on your first term and what it's going to do from there. All right, and then the last thing we're going to worry about today is if they give you basically a data set. All right, and when you say data set, basically here's what it is. It's basically a set of ordered pairs, but they give it to you in a neat little chart, so you're not worrying about having to go back and find all the ordered pairs. Okay, and to do that one, here's what you're going to do. You're going to do one simple little thing on this one to go back and get what you need, but basically is this. You're going to just subtract the y values. And one thing I've had to add in over the last couple of years is that when you do that, make sure you do it in the order that it's given. Because I had some people one year, they kind of bounced around and did they put them all in order from least to greatest. And I'm like, no, you have to based on what's the order that they give to you. Because it should be that the x value should be in order. So these basically should kind of pair it with those. So subtract the y values in the order given until the difference is the same. And the number of times that you subtract that's equal to the degree. Okay, so here's where we go with this one. So we're going to write down the y values. And you can show this a couple of different ways when you do this one. Here's what I always kind of like to do with it. Is basically I'm just going to go ahead and say, all right, I'm going to do 16 minus 7 that's here. So if I do 16 minus 7, I'm going to put the answer right in between those two numbers. 16 minus 7 is 9. Then you do the same thing with the next two numbers. You do 7 minus 2, which would be 5. Do 2 minus 1, which would be 1. And then you do 1 minus 4, which would be negative 3. Okay. Now, and that's, again, assuming that all the x values are just one number apart to kind of go through this one. So there's the first time that we subtracted all the numbers, or the y values, and we didn't get anything the same. So now we're going to do the same thing again. Now we're going to do 9 minus 5, which is 4. We're going to do 5 minus 1, which is also 4. So this one comes out to be a 4. We're in business here. And this one is 1 minus negative 3. But if you do minus a negative, that makes it a plus. So that's really 1 plus 3, which would also be 4. And that's the second time that we subtracted. So for this one, the degree would be 2. All right. Now, usually some people ask, well, what if we don't ever get a number that's the same? Well, eventually you have to. Just for, you don't have to write this down. This is just something, because let's say that this was 14 over here. Not that it was, but so you don't have to write this down. Just saying a what if here. Well, what if my pencil works? There we go. Let's just say that had been 14. So you subtract those two, that would make it 10. If you subtract those two, that would be 0. Still not the same, but then when you do 10 minus 0, you get 10. Well, that's the third time. That would be the fourth time. So finally, this one would be a degree of 4. So if you get down to where there's only one number, then the answers have to be the same. So that would be the worst case scenario, is you just keep going down and down and down and down until you've got one number left, and then the numbers have to be the same. But again, we're just throwing something out there of a what if, because some people always ask that, like, what if we don't ever get to the same number? Well, eventually we will. In this case, this one would have stopped here at 2 terms and we'd have been okay. But if it were different numbers, you just keep going until eventually, if there's only one number left, then it has to be the same.